Hi everyone, I'm here today to explain the code of the SOM Robotics master and slave cars. First, in the master car, we have added the library of virtual wire, which helps to transmit and receive the signal. The transmitter and receiver we have used are of 433 megahertz. In the master car, we have created two global variables. One is character T and the other one is character data. The second variable is a pointer variable. Then in the setup function, we have set the pin modes of the motor driver 4, 5, 6, and 7 to output pins. Then we have started the serial begin at 9600 baud rate and set the transmission pin to pin number 3 of Arduino. Then 2000 transmission rate is set bits per that is in bits per second. In the low function, we have seen that if the serial is available, like if the Bluetooth is receiving the signal, then the received signal is sent to T, the variable we have declared earlier. The signal is stored in this variable. If the variable stores a F, capital F, then the data of small f is sent to the receiver module using the below function, which is virtual wire send function. This virtual wire send function contains two parameters. The first parameter converts the data into unsigned 8-bit integer variable, and the second function determines the length of the data received. Then the virtual wire creates a wait function which is executed till the time the transmission is not complete. So it will temporarily pause the program for the proper execution of the sending data. Then the forward function is called, which is used to control the motors to go in the forward direction. Similarly, it stands for G, that is for backward function, and in the similar way the data is sent, and for left, right, and stop. Here at the bottom, we have created the forward, backward, right, left, and stop functions. These are used to control the directions of the motor. Now we have come to the slave part of the SOM robotics cars. Here again we have included the same virtual wire library. Then we have created a data variable that is of character data type and is a pointer variable. Then in the setup function, we have again created four pin modes for the motor outputs. Then begin the serial monitor at 9600 baud rate just to check and print the values to remove any bugs and errors. This can be also removed, it is not much needed. Then we have set the receive pin to pin number 3 and set up the transmission rate to 2000 bits per second as selected earlier. These must be same. The transmission rate needs to be same. Then we have started listening. This function, start function, makes the receiver module start listen to the frequencies it is receiving. In the loop function, we have created a buff array which stores everything that it receives, and this buff array is a unassigned 8-bit integer type similar to the previous one. Then this is a buff length function which determines the maximum length of the message received. It is also in the same data type as earlier. Then this serial print is used to show at the serial monitor that what is being received. It prints the zeroth element of the array. If the message is received and it is true, this condition is true, then it comes inside the loop. If the message is of F, then forward function is run, of G, backward function, L for left function, R for right function, and S for stop, as we have also done it earlier, similar way. But here the forward, stop, backward, right, left functions have different motor configurations for their directions. So this must be kept in mind. Here is the final video demonstration of the prototype. This is the slave and this is the master car, which includes the Bluetooth and the transmitter. In the slave car, this is the receiver that receives the signal.